Hello viewers, welcome back to a video tutorial on AgentGrid. So in this episode we'll be talking about a newer concept, the behavioral workflow with AgentGrid SDK. In our earlier videos we would have explained workflows of different categories. So get a pattern, a simple workflow where static connections of agents were there, a multi-level workflow, a dynamic and a static level of agents were connected with the workflow manager, hierarchical different levels of agents workflows, sub workflows were created and connected, and in the hybrid where we connected a static, a dynamic and static workflows. So we call this as an agent flow, and in this video we'll talk about the behavioral flow. So the behavioral workflow with AgentGrid SDK. So we basically in this video will demonstrate how to build an orchestrator workflow of agents using AgentGrid SDK and AgentGrid workflow engine. Here we are going to define behavior to agent. Generally the agent code, the behavior of agent code is written within the agent, the code's py file. But here we are going to use an external system, call it as functions, which is a system which is co-developed along with AgentGrid. So we use the system to define the behavior of an agent. So here the example that we have taken here is code generation and testing workflow, and the behavior here we created using three functions, and these three functions are reusable functions. So we create the function, we deploy the function, and these functions can be used by any other agents. So since these functions does some unique work, now we club them and we create as a graph. So graph of functions are created, and that graph defines a behavior. So this graph will be attached to one of the agents in our example. So that's what we call it as behavior of an agent is set using the graph or functions. So the directory structure of the folder, you will have a node folder, specs, deploy, run, and graph. So the node spec, deploy and run we have explained in our previous videos. The nodes folder will contain all the Python codes of the agents. The spec folder contains the registration files related to the agents, and deploy and run is related to the workflow. So you will deploy the workflow, you create the workflow which connects the agent in a what manner. So all those defined in this workflow spec file. And we have a graph file here, a graph folder here, which is a new folder. It contains the files related to all the functions. So as we told, we have three functions here. We'll be seeing three folders for these functions. It's registration files, and its deployment, and a graph spec file and its registration. So let me just go take you to the folder, a behavior workflow, deploy and run, graph and nodes and spec folder here. So the graph is a new addition, a new folder that we have added. So let me show you a diagram. So here user requests a workflow manager knows what is the input. So according to that, it will pass the input to the input agent, and the input agent will give its output. And then we have a second agent, only two agents we have here. One is the behavioral code agent, a creator agent, and a reviewer agent. So the output of one agent will go to the output as an input to the second agent. And in this agent, it is a dummy file, but what it does is it calls an graph, the graph that we have created using the functions. So there are three functions that is created and deployed: the code validator deployment, and test case generation deployment, and test runner deployment. So these three connect as a graph, and the input coming to this agent will go to the first this graph. So the output will be coming out of the test runner. So these all are compatible, meaning they know how the input and output will come from each functions. They know it very well, and the final output will come as in workflow output for a user. So we'll go the code section of this, and also the reviewer agent and behavioral agent in a moment. So let me just go to the codes. So I'll go to the node section. So here we have a behavioral code agent, and we have a reviewer agent. So let me open the code creator agent. So code creator agent, it has one DSPy signature to generate the code, and when it generates, it has to give us a string, which is a Python function or a Python code generated from the LLM, and a function name, which is basically the name of the function, and a description. So this is what we are asking from the DSPy signature. and it gives a input is a user request and code generation as output field. So the function is very simple here. The given we have to send a user request key in our data, and that user request is taken and it constructs one particular user message. So basically we are getting that user message, and we this is a task registry key in case to know our history of tasks, right? So I can use this registry, which is a simple Pythonic dictionary with the task ID as an input. So user request, model name, and a session ID is added here. So there is, it's nothing much doing right now, but I'm just keeping it so that we can use it in the later stages. So here the executor is called. Basically we are talking to the LLM generates the code, and from that we pass the code, function name and description, and we create a job output where user request is added there, the code that is generated, the function name and descriptions are added here, and then we pass it to the as a result. So the workflow manager takes this result, since it knows the second agent is the reviewer code, so it will hands on the output to the reviewer code. So once reviewer code, we get again the job will come here, and we break it down, the input, then we extract the code from it, we extract the function from it, and we extract a description from it, and the extracted contents are passed. Here we have one special unit, again one SDK, so self graph dot execute graph. So to execute the graph, you require a graph URI and the input data. Input data is already constructed. The graph URI is defined in the top. So here is the graph URI code analysis pipeline 3:1.0 stable. So basically the graph URI is given to get executed. So this function will, this particular call, or the SDK will take care of running this particular URI and passing on the input, and it is an wait. So basically until unless the output doesn't comes back, so it has to wait. So it is basically sync response. So a sync response has to receive, so result has come, and then it will pass as an output to the agent's output. So let's see what this basically does. So what this graph URI is, we'll see. So these two agents, basically for the second agent, the whole what agent has to do is defined by this particular graph, so nothing else is there. So even if you, let's say you want to have multiple graph as well, so that's also possible. So based on the input, you can run one graph, you can run two graphs. So different behaviors of an agent can be called within this particular agent code. So let's go back to the workflow behavior. Let's go to the graph. So node section and spec section and deploy and run, I will not show. It will have the same registration files. So let us go to the graph. So here I have a code analysis folder. So in this folder there are three functions are there: a validator, a test generator, and a runner. So let's go to the validator. So the first here is a validator. So as you can see, there is a code folder. In that code folder there is a function.py and requirement.txt. so the name has to be exact. So it has to be the Python function that you are going to deploy it as a function. It has to have a function.py as a name and a requirement.txt. if in case it has a new requirements of any Python library, you have to provide a requirements.txt. so let me open this function.py. So there is a class name v1 policy rule. So you should not change this class name. So you have to have this class name, and this class has a two functions. So one is init and one other is a eval. So in the init, so basically it initializes certain parameters that it might need. Since we are this policy, this function is going to use the LLM, we are using an OpenAI here. So if in case you want something else, so you can use those libraries of those like Gemini is required, so you can use GenAI library here. So with the help of OpenAI client, I'm going to create a client and models parameter also. I'm getting it from the silk.parameter. So basically you are getting a rule ID, settings, and parameters. So with this you can initialize whatever you want. And the eval, in the eval, so you get a input data and a context, so and the parameters. So from the input data I'll extract the code and a description of the code. And here what I'm doing is I'm just evaluating the this, I'm calling a function known as it's an internal function, validate and optimize. So I'm passing on this code and a description. so to the this particular function, and this function has a prompt. So basically you are an expert Python code reviewer, analyze the following Python code and provide a correctness check, identify any bugs, syntax or logical issues, and optimization suggestions, and also an optimized versions of the code. So you have to give a three things: a correctness check, so is valid is what it is, and what all the issues are present, optimizations if in case any available, and optimized code. So this is the JSON schema that we are expecting it from this particular prompt, and we are sending it to the LLM, and we'll get the response from it. So this response is sent back as a output of this particular agent. So here function. So here the input data is added, and a new folder is added, code validation, and validation response is added here. So this is written from this particular function. Then as you can see, the output of this goes to the test case generator. So let me open a test case generator. So we have a function validator, we have a test gen folder. Here also the code folder is there. You have function and requirement.py. So in the function.py, again same classes, AIOS v1 rule, policy rule, and init and eval functions are there. So it does the same thing. So basically it breaks the input and calls the generate test for internal function. And here you are a Python expert test engineer. So basically you need to generate some whatever the number of tests you want. So test cases, you need to generate diverse test cases for the Python function. This is the function name, and covers the normal inputs, edge cases, boundary conditions. Every value in input and expected output must be plain JSON serializable type, and respond only with the following structure. So it has to give the function name, test cases. So for each test cases, descriptions and the input of that, and the expected output it has to generate, the LLM has to generate. So in this function we are making in these two functions we are making a use of a help of LLM. So the output that will get from this particular test case generation, so we'll pass it on to the next agent, and next function, and here we created a test cases as a new dictionary we have created. So in this line we have third as a test runner deployment. So basically this particular function, the third function, is supposed to run those test cases generated. So let us see the function.py here. So again same classes, AIOS v1 rule, policy rule, and then init and eval. So in the eval we are basically taking the code, the function name, the code validations, and the test cases, and we are just checking the boundary conditions of it, and we'll call a compile, and we are passing a code and a policy, the policy code, and a exec. So basically we get in compiled code here, and that code is what we are going to run in this particular function. So compiled code and the function name, and we are giving each of the test cases, what we have got from the previous. So basically we are going to run this test cases for each of the test cases, and then the output of this we'll collect it, and we create a status, okay, descriptions, input, expected output, actual output, so and the passed or not. So those kind of outputs will dump, or JSON will be dumped. And at the end, once all the test cases are passed, so we'll do again a summary of it as well. So we add a test results, test input will be added, test results will be added, and a summary will be added from this particular these three outputs are added from this guy. So basically we have a code validation folder, test input folder, test results folder, and a summary folder will be available as an output. So this output will come back to the second agent, and the second agent will pass on that to the user. So this is how the functions are written. So let's go and see the demo of these agents in action. So if you let me just condense all the steps here. So as you can see, the steps are very similar. So you have to register and build the agents, then deploy. The second, generally we'll do a deployment of agents, but we have, in this case, we have functions, right? So we need to deploy the behavioral functions first. We need to deploy the functions, we need to build the functions. I mean, we need to create the zip files of those functions, we need to upload those files. So I'll walk you through the process. So other steps, the deployment of agent, registration and deploy of the workflow, and running the workflow demo, and rest all things remains very much same as the other examples. So let me go to the registration and build. So here we need to register the agents. So we have 2 agents, and those 2 agents will be registered with their JSON specs. And to build the Docker, you can run this command, so it will build the 2 Dockers required. And then I'll go to the deployed behavioral functions. So here the code folders, so as I told, you need to maintain the structure for sure. The name of the folder should be code. In that there has to be a function.py and a requirement.txt. That those things has to be very intact, so there should not be any change in it. And now I call a create zip.bash, so sorry, sh. So if you go to each and every folder, so in the code analysis folder, function3 runner folder, there is a create zip.sh. so if you check that, what it does is basically it zips the it creates on file name .zip, and it zips the whole code folder itself. So at the end of this, we get basically this zip file. So we are going to get 3 zip files from these 3 functions. So those 3 functions are created from this cell in the Jupyter notebook. So yes, it has created the 3 zip files. Now these 3 zip files has to be uploaded to the internal function server, where the function system can take these files, because right now the zip files are within your node or your machine, so they are not accessible for the function system. So we need to upload it. So for uploading, you need to just click this upload.sh. So once the functions are uploaded, so we need to register those. So basically we have a zip file, and we have an we have uploaded the zip file right now, and we need to register those functions. For registration, we require the spec file. So let me show you the spec file of the functions. So here the registration, test generation, validator, and runner is there. So let me just show you the first one, the function validator. So it is similar to registration of agents, so where we'll have an API. So we have a /policy, and to that we need to provide a big JSON where it has a name, version, release tag, metadata, and the input schema of the policy, and the output schema of the policy. So where the input schema is an object, it requires the properties are the content in that object will be code, function, and a description. So these 3 things will come for the validator. So these 3 are the inputs. So next is policy output schema. What will be the output of this policy, so or the function? So that is defined here, object and properties. So these are the 3 outputs. So output will have code, function name, description, and a code validation. Because this is a validator, a code validation for a new folder will be created along with the 3 inputs that it has received. So, and this is the structure of the code validation. Again, it is an object. It has properties like is valid, issue, optimization, optimize course. So this kind of things, and they are either boolean, array, or a string that you need to define. So setting schema, parameter schema. Right now I don't have any settings, but the parameters I need to pass on the OpenAPI key and the model name. So these 2 are my parameters. So policy settings, I don't have it. OpenAI key and policy parameters. So this is the what you need to send. This is the schema, and this is what I need to send right now. So open API key and open policy parameter. So this is basically when we are registering, it will be replaced by our actual OpenAI key that we have in our env file. So any such files, right? So any secrets, we'll keep it in env file. So that will be used in our it will be replaced with our the env file content, and it will be pushed. So this JSON file will be registered with the help of this particular sh file. So here we are to read the env file, we are using this particular piece of code to read the env file, which is present in the root folder of the git folder. And here one other important thing is the policy upload URL. This is the URL that we get when you upload this particular zip file. So we'll when we upload it, we'll get that URL, and that URL is in again the env. So that URL is very static in nature, so we have kept it in the env file. So this is for the one particular function, and similarly we have for other function as well. So generation and runner agent as well, we have it. So once you register it, so let's register the function now. So the functions are registered, and now we need to deploy those. So the registration is basically it goes and sits in the DB, and where you can do an search as well. So basically it will not have a runnable component. It just sits in the DB. So we need to deploy it right now. So let us deploy these 3 functions. So in the deploy, let me show you the deploy. So function 1.sh. So what it does is basically we have a slash function deployments create, we have an executor. In that executor we are going to deploy this function. So what is the name? So we are giving one deployment name. And what is the URL? So code validator, this URL is nothing but what you get here, the name, version, release tag, right? So the URL of the function, so that we need to give here code validator 1.1 stable. And what is the parameter? We have two parameters here, OpenAPI key and model key. So that is again coming from the env file. And this is the model, OpenAI model name. And replicas, I want only one replica because right now it is testing. If in case you have many replicas, you can if you have so much of loads, you need to increase the replicas. Or else if you want an auto scaling or anything, right? So we can write an auto scaling policies for the this particular function, how to auto scale. So function metadata and function tags. So some so that these tags you can use it later on anywhere searching or anything. And also it's a metadata, so description of this particular deployment. So with this help of this SSUI, basically we are going to create a deployment which is nothing but running instance of this particular function. So let me just deploy this. So before that, so let me just show you the there is one single pod. And let me just run this. So once it is deployed, so let me just check this. So you have three other code validator function, test case generation, and test runner deployment. So three new deployments of the function has come up. So now let us see the graph. So though these three functions are there, they are individual entities, they are not connected at all. So we require an entity known as a graph. So let us go back to the graph. So here we have a graph.json, graph registered unregistered.sh, and graph.sh. So in the graph.json, so we have graph name, graph version, graph release tag. So this is what we have used in our second as a graph URI. So graph URI is the but code analysis pipeline 3 1.0 stable. So that's what code analysis pipeline 3 1.0 hyphen stable. And we have other metadata. So graph function IDs. So basically these function IDs corresponds to what those three deployments names. The deployment of these three functions. So the deployment here is code validator deployment 1, right? So that code validator deployment 1 is here. It is not the URI of the function, it is the deployment name of the function. So code validator deployment 1 and test case generator deployment 1 and test runner deployment 1. So these are the three deployments of the function I need. So I'm just mentioning it in the function IDs. And then we have a graph connection data. So basically this defines the how graph is connected. So here the first code validator deployment output goes to test case generator deployment, and test case generator deployment output goes to runner deployment. So this is a very static graph here. So static graph is constructed using in the graph connection data. So rest things I'll leave it for your understanding. Searching tags, descriptions, input schema and output schema. So that you need to define for this particular graph. So the graph output schema is, it will give you the code validation folder, test input folder, test result folder, and summary. So, and whereas here the input is code, function, and description. So these are the input schemas of the graph. So let's go back to the graph deployment. So this graph.sh, what it does, it basically registers this graph.sh. So slash graphs is a folder, and we need to give the graph.json file, and it will get registered. And now since this graph is just the connection, any the function system, right? So any our system, if you give this URI, that's more than enough. So basically it will pulls the three zip files, and it will execute those three zip files in a connected manner. So we just have to register them. It is registered right now, and to test it, we have a call.graph. So I have a bash file here. So it will do the same job of what we have seen in our second agent, like whatever the graph execute, the graph self graph.execute was there, right? So just taking a graph URI and input data. The same thing I have a call graph. So basically slash graph execute graph. So here we need to provide the graph URI and input data. So basically the code, function name, and a description. So it will execute the this particular graph. So let me just run it as a showcase. So now it will bring those the functions are already deployed. The system, the function system which will just take care of connecting those three functions and releasing some output. So here, as you can see, we have a code validation, and then a summary, and the test inputs and a test results. So we have the all the keys that we have defined. So this is the output of the calling a graph. So now that same thing is called within the as a Python API, Python SDK self.graph. So let us deploy the agents now. So let me deploy the agents. We have till now we have deployed only the functions, nothing else. So let me verify the agents. Yes, they have created 5 seconds back. So only 2 agents, one is code creator and reviewer. And then let me register the workflow, because this the whole 2 agents are connected as a workflow. So I have created the workflow, and let me have registered the workflow, and let me deploy the workflow. So workflow manager is created, which is running at 30986. So for every manager, whenever you create and deploy an workflow, the workflow manager will be running in a separate port. So this is the service port of the workflow manager. So let me show you that workflow manager. So here simple behavioral workflow manager runs like since 18 seconds. So let us run a demo. So I have a Streamlit app running already. So the Streamlit app is running here, and so let me just give you the input. So what this input consists, let me just go back to the deploy and run workflow input. So here API/execute, and user request is create a function for adding 2 numbers square root. That is, if I send 4 and 9, a sum should be 5, as 2 is a square root of 4, and make sure code generated is just a single function. So I'm not asking a multi-function, single function. So let me pass this input to the workflow. So running an example. So let us see the dashboard here. So input, and the output from the first agent is a code it has to generate. So if code is generated, it's a square root, add square root is the function name, and returns the sum of the square root, so description. So now it has come to the second agent. So second agent output also has come. So let me see the output here itself. So same structure of the previous one. So basically, since it's a workflow, it will give the output of each agent here, my behavioral code creator and my behavioral reviewer. So we have a code validation, a summary, test inputs, and a test results. So in the summary, it has summarized 3 has failed, 2 has passed, and 5, total of 5 tests. So why it has failed, it has its own reasons, like maybe negative numbers, things like that. So yeah, so this is the output of the agents now. So the workflow, because of the behavioral nature that we have set for the second agent. So one other example we want to show is something known as chat server. Let's say you want to interact between any of the agents. Let's say the agent wants to get some information from the user, or through and fro communication is required. So we have something known as chat server. So I have given an example of a chat server. So right now, let's say I have 2 agents already running. I want to connect to one of the agent, and I need to pass something to it directly from the client. So let me just go to the code client.py. So it is available in the example section, examples chat servers. So let us go to code WebSocket. So it's a WebSocket app. So it requires basically, so here it is a code for loading a env file. So it requires a WebSocket URL, so that we require it, and then a subject ID, and then subject ID. Why it is required? Because which agent you want to talk. So we require a subject ID. So here it is not what is there in the workflow name, my agent behavior, not like that. It's a subject ID, and it's some test data that I have created in the top. User request function to add 3 numbers in Python. Basically, it will generate a func code, right? So I have just asked her, this is the user request, because the first agent expects a user request as an input. So this is the test data, and I have a run function here. So everything is async. So with async, WebSocket connects WS URL as WS. WS is a WebSocket object now, and what it does is first it initializes. So initialization is required. So you need to send type equal to init and the subject ID to the which agent you want to talk to. So you are sending it, and then JSON loads. You will wait for the response, the WebSocket response. ws.receive will give you the WebSocket's response. So in that, the when you are sending it, it is an init, and when you are receiving it, it has to be an session type. Basically it will create a new session. So once a session is created, you can use that session ID to keep track of communication to any other, any other communications that you want to maintain in this particular client and the agent, right? So that session ID is very important. So you need to use the session ID. So session ID, subject ID, we are printing it here. Next, I'm generating an some unique the unique ID using UUID. We call it as task ID, and then it is a task message. So I'm constructing now a dictionary for the next input. So though I have initialized, I need to talk to those agents right now. So type, task ID, and task data. So I'm going to create a new task for the agent now. So these three are important here. Type is a message, and task ID and a task data, and then we are sending a WS send with the JSON, this JSON, and this JSON, once it is sent to the agent, it will go to the agent. And since we are using an behavioral code creator agent, basically first agent, and we will get the response from the we will get a response from the first agent, and that we are showcasing that we are printing the output of the second agent, the first agent. So since we are directly talking to the first agent, it will not go to the second agent. We are not talking to the workflow manager here, we are talking to the agent only. So whatever the output of the agent, it will get returned to the return back to this WebSocket. So this way you can use this particular client code to talk to the agents directly without let's say you are in, like, you have a 5 agents, they are connected serially, but the third agent requires something from the user. So in such cases we can use the chat server, where the input the input to the third agent need not come from the first agent. So this chat server can be used directly to get input that is required. So this is the chat server. So let me just execute this. Yes, so now what you are seeing here is let me show you the output. So first init is called, so this is the input init, and this is the subject ID, and then we got a response saying that session, this is a test session, and session ID is this. So it's a randomly generated session ID, and then with that session ID I'm going to create a task, and in the task type is message, task ID, task data. In the task data I'm putting the session ID and the user request. So waiting for delegate response, this may take a moment. So once we received the response, in a printed, you have the data and the output. So the data is what the internal things, like what is input and what is the exchange it has used, all those details are there. And then we have a output. So the output has a error data, is error, job output, which is same as what you are returning from here. So basically the agent result class. So the agent result class content is here. The job output is error data. So job output metadata, job output trace, task ID. So all those details are here. So this is the code description, function name, request. As you can see, you are not getting anything from the second agent. You are getting only from the first agent output. So the first agent output has come here. So this way we can use the chat server for communicating with the agents. And since it's a demo, now I'm going to do a cleanup operation. So basically you need to remove the workflow and then unregister the workflow, and then remove the agents. Once your agents are removed, they will be still in the DB, so you can do an unregistration if you want. So unregistration removes the agent spec file content from the DB. And then now we need to do it for the functions. So let me remove the functions, because functions as a deployment, I have a API for removal of those deployments. I have removed the functions deployment, and since we have registered the functions, I need to remove those registrations since I don't want it right now. So I have removed it. So yeah, you can see, right, there is no agents. Let me do it again for the removal also. It will show you it is not there. Then we need to unregister the graph. As graph was registered, we need to unregister it if you don't want it. So if I run it again, you might see an error saying that it is not available. So this way you can use functions or combinations of functions to create a graph and define a behavior, and you can definitely have multiple such behaviors can be used within a single agent. So that's it for the video. Thanks for watching our channel. Don't forget to subscribe our channel and keep watching and keep supporting us. Thank you.